All right, students of population A and population B are each sampled randomly and independently. Conduct a chi-square homogeneity test, alpha equals 0.05, to determine the distribution of gender, to determine if the distribution of gender is the same for each population. So we're sampling A and B separately. That's why it's a homogeneity test, not an independence test. We're going to check for conditions. So I'm going to rend. We have random samples. We have independence between samples and within each sample, right? Independence within each sample, right? And the two samples are independent, right? And then instead of normality, we're going to say numerous counts. My expected counts are greater than 5, all of them, okay? Now we state our null hypothesis. The distribution of gender is the same in each population. And my null hypothesis, my alternative hypothesis, the distribution of gender is not the same in each population, okay? Okay? And now we're gonna get our expected counts. Our expected counts equals row total times column total over total, okay? All you're doing is scaling by this. So 80% of the counts are gonna be boys if I take the total, so 80% of this is my expected count, okay? Or we can just follow the formula. If I wanna get my expected count here, row total times column total divided by total, okay? Or you can just do it proportionally. I need 80% of this, so that's 4 and then 1. 80% of this, so that's what, 40 and 10, okay? And now my x squared statistic, how many degrees of freedom? Rows minus 1, columns minus 1. So 1 times 1, I only have 1 degree of freedom. And it's going to be the sum of the observed minus expected squared over expected, okay? So we just got to do that. So I have 4 minus 3 is 1 squared, right? So 1 squared over 4 plus, right here I get 1 squared over 1 plus, right here I get 2 squared over 40, and then I get 2 squared over 10. Now we use our calculator, okay? Just use your calculator, so I get 1/4 plus 1 plus 4/40 plus 4/10. So I get 1.75. So now I'm gonna go to my, right? My chi-square is skewed. So I wanna go from 1.75 to infinity on my calculator, CDF. Okay, so second bars, x squared CDF, lower is 1.75, upper is 9999999, close to infinity, and degrees of freedom is just 1. So I get my p-value, and I get my p-value is 0.185. So that is greater than my alpha level, greater than A. So we fail to reject the null hypothesis, okay? We fail to reject the null hypothesis. There is not enough evidence to conclude the distribution of gender is not the same in each population. Okay, there we go. Good job.